Good morning, Mr. Hardale. Today, myself and Ms. Hassan Amsterdam will be presenting on Earth and space. To begin with the structure of the Earth. Earth is the third planet from the Sun and the fifth largest planet in the solar system when speaking of size and mass. The structure of the Earth consists of the crust, mantle, inner core, and outer core. The Earth's crust consists of a variety of rocks, soils, and basically everything that is visible above the Earth's surface. The crust occupies less than 1% of the Earth's volume, and it floats on the layer known as the mantle. It is made up of thick, solid, rocky substances and amounts to about 85% of the total mass of the Earth. The mantle is about 1,800 miles thick and is by far the largest layer of Earth. The Earth's outer core is made up of a very hot substance called lava. The lava is believed to be made of nickel and iron. And lastly, the Earth's inner core. This layer extends another 900 miles towards the center of the Earth. It is believed that this part is as hot as the surface of the Sun. Secondly, we have the structure of the solar system. Our solar system is made up of our stars, the Sun, and everything bound to it by gravity. Our solar system extends much farther than the 9 planets that orbit the Sun. These planets are as follows. Mercury. This is the closest planet to the Sun. Venus is the second planet from the Sun, and it is the hottest planet in the solar system. That is so because it has high amounts of carbon dioxide, which traps heat inside of it. Earth is a unique planet with suitable climatic conditions, landforms, and water bodies that support life in all forms. Mars is often known as the red planet because of its reddish appearance, and it is home to some of the largest dust storms. Jupiter is the largest planet in our solar system. It has 4 moons. Saturn. There are about 150 frozen moons around Saturn. The largest one is called Titan. The planet has beautiful rings around it made up of dust and ice. Uranus is a very cold planet with temperatures of about 244 degrees Celsius. It takes about 84 years to revolve around the Sun. Neptune takes about 165 Earth years to revolve around the Sun. It is also known as the ice giant, and it has about 121 moons. Then there's Pluto. The order and management of the planets and other bodies in our solar system are due to the way the solar system is formed. When the solar system was young, only rocky materials could withstand the heat of the Sun. For this reason, the first 4 planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. Meanwhile, materials we are used to seeing as ice, liquid, or gas settled in the outer regions of the young solar system. Gravity pulled these materials together, and that is where we find gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. Thirdly, movement of planets and the moon. The invisible force known as gravitational force binds planets to the Sun and its moon. It's a power of fascination between the two bodies. The amount of matter in the bodies, their mass, and how far apart they are all affects its strength. If somehow magically gravitation suddenly vanished, the planets and their moon would vanish into space. Fourthly, seasons on the Earth. The Earth spins on its axis and it rotates once every 24 hours. Seasons occur as a result of the Earth's tilt, or on the other hand, inclination. The fact is, some regions of the planet receive more solar energy than others. Our planet's slanting orbit around the Sun is caused by its axial tilt or obliquity. This means that different parts of the planet point toward or away from the Sun at different times of the year. The northern hemisphere receives the Sun's greatest direct energy on the Earth around the summer solstice. when it shines most directly on the Tropic of Cancer, 23.5 degrees north of the equator. The southern hemisphere receives the greatest direct energy from the sun during the winter solstice, when it shines most directly on the Tropic of Capricorn, 23.5 degrees south of the equator. In a nutshell, when either hemisphere has long days in the sun, the temperature rises and they have summer. On the other hand, when there is winter, it gets cold because either hemisphere spends much time out of the sun and is exposed to the dark and cold side of space.
Phases of the moon. Moonlight is the sun's light reflected off the lunar surface, which causes the moon to transform from a new moon to a full moon and back again. The lunar cycle, or phases of the moon as we know, involves the moon's rotation around the earth, which causes it to become nearly invisible in the night sky. The new moon is the invisible phase, while the waxing crescent phase is the crescent phase. The first quarter, waxing gibbous, and waning gibbous phases occur as the moon moves from full to invisible. The last quarter phase is half illuminated, followed by the waning crescent phase, where the moon shrinks back to a less than half full crescent. Let's talk about tides. Tides are the rise and fall of sea levels caused by the gravitational force of the moon, the sun, and the earth's rotation. The moon's pole affects the earth's ocean, causing bulges on the side facing the moon and the other side. The earth rotates on its axis, causing constant changes in the bulge location. High tides are larger while lower tides are smaller. We have spring tides that occurs twice a month when the sun, moon, and the earth forms a line, while neap tides occurs when the sun and the moon are separated by 90 degrees. Eclipse of the moon and the sun. An eclipse happens when a moon or planet blocks the sun's light. Solar eclipses and lunar eclipses are the two forms of eclipses that can take place on Earth. When the Earth moves in front of the sun and moon, it restricts the moon's access to sunlight, causing a lunar eclipse. Similarly, a solar eclipse happens when the moon obscures the sun's light and casts a shadow on Earth. Natural and artificial satellites. What is a satellite? A satellite is something that circles or revolves around a planet or star. The only naturally occurring satellite of Earth that orbits a larger body is the moon. Humans create satellites that are designed to orbit other celestial bodies. Now, these man-made satellites are essential to daily life on Earth. If it wasn't for these satellites, we wouldn't have GPS, or we wouldn't be able to make phone calls, or even the internet, among other things. The largest man-made satellite, which is the International Space Station, houses and supports the human population, and other satellites do astronomical research. Satellites, both artificial and natural, are important parts of our daily life.
Here we have the structure of the Earth. A model made by myself, Angelina Prasad, and Miss Kathleen Amsterdam. We have the inner core, outer core, mantle, and crust.